Hi guys, welcome again to my physics class. This time we're gonna talk about harmonic motion. Now, this is in chapter 11, section 2. First example is we're talking about a simple pendulum. We already talked about it in the presentation, but right now we're gonna solve this sample problem of simple pendulum. Let's see. What is the period of a 3.98 meters long pendulum? What is the period of a 99.4 centimeters long pendulum? So we're talking about two questions, number 1 and number 2, and in both I'm looking for the period. I'm looking for period and I'm looking for period. Now, what is the equation that I will use if I need to find period? This one right here. For simple pendulums, I have period equals 2 times pi, square root of length, pendulum's length, which is like the string size for that saying, and divided by gravity. So basically, I just need to know its length, because gravity is a known given. If it's not specified other gravity, we're going to use 9.81, and 2 and pi are constants. So for the first question, let's see, what are the givens that I have? I just have length. I just have length to be 3.98 meters. Now, how do I apply the formula? Easily. Period equals 2 pi square root 3.98 meters divided by 9.81 meters per second square. So here I will cancel meters with these meters right here. So my period will be 2 pi square root of this division, seconds to the second power. So we have 3.98 divided by 9.81, 0.406. Now square root of my answer times 2 times pi gave me period equals 4 seconds. Easily, right? Now let's solve the second question. It says, what is the period of a 99.4 centimeters long pendulum? Now, in this given, the only difference is that my length is not in meters, it's in centimeters. That means that we need to perform a conversion before we plug in the givens. So we have 99.4 centimeters. We need to convert it to meters. So we say that there are 100 centimeters inside 1 meter. Cancel here and there. And it's going to be a little bit less than 1 meter. 99.4 divided by 100 is 0.994 meters. Now what's next? Applying the formula. Period equals 2 pi a square root of 0.994 meters divided by 9.81 meters per second square. As I told you before, cancel meters. So here inside my square root, I will have 0.994 divided by 9.81 square root. So this is going to be 2 pi square root of 0.101 seconds to the second power. This is, we perform everything, times 2 times pi. My period here is 2 seconds. Voila, there you go. Now let's take a look at the second example. A desktop toy pendulum swings back and forth once every 1 second. How long is this pendulum? So, what are my givens here? We have givens okay, now let's take a look. The only given here is 1 second. When we talk about seconds, we talk about periods. So the first given is, and the only given is, period equals 1 second. Now what am I looking for? How long is this pendulum? So that means I'm looking for length. Length is going to be unknown. So from the equation I isolated previously for length, and this is the equation that I have already ready to be used. So we say length equals period divided by 2 pi raised to the second power times gravity. Gravity, you know it already. Period is given, just let's plug in the values. Now what if the period is given in a different unit? You have to do conversion. Period should be in seconds. Divided by 2 pi raised to the second power times 9.81 meters over second square. My length, it's gonna be 1 over 2 pi okay, there you go, 1 over 2 pi. That answer, I'll raise it to the second power, and then I will multiply times gravity, and my length is 0.25 meters, and that's it. Easily, right guys? Now let's do the third example about simple pendulum. There you go. What is the free fall acceleration? Look at this. I'm asked to find free fall acceleration, also, or aka gravity, at a location where a 6-meter long pendulum swings through exactly 100 cycles in 492 seconds. So this exercise is a little bit more complex, but not too much. Let's do it. So I have to find free fall acceleration or gravity. They are giving me length. They are giving me this 100 cycles in 492 seconds. Okay guys, look, I had a mistake in the formula, so I did a correction in the isolation of gravity. This is the correct formula. I already checked twice that it's correct. And let's go to the let's just plug in the values. Let's see about the givens. Gravity unknown is the question. We have length 6 meters long, and now this 100 cycles in 492 seconds. This will help us, as it involves seconds. This will help us to find the period. So period is times over second, or how many times something passes through a point. As we're talking about a pendulum, is how many times does it move back and forth in this case 492 seconds. How many times? 100 times. So that means that this pendulum moves 100 times in 492 seconds. Okay, now how do I turn this into my period? A period is number of times, I will say like that, divided by 1 second. Now how many times? 100 times divided by, sorry, this is This is frequency in hertz. Okay, 100 divided by 492 seconds. So this will give you 0.203. In this case, we're talking about cycles. So cycles over second. Now, how can I get seconds? Raising it to the negative first power. So we're going to have 492 seconds. So my period, you can calculate the period by using this formula. Period is equal to frequency, which is measured in hertz, raised to the negative first power. Now let's see, not this one move. Let's see. Gravity will be equal to 6 meters divided by 492, 4.92 seconds divided by 2 pi raised to the second power. So how do we do this? 4.92 divided by 2 divided by pi raised it to the second power. Now 6 divided by your answer, gravity, equals to 9.79 meters per second squared. And that's it, guys. Now let's review this exercise because I think it's the one that is a little bit more complex. So by taking out the givens is kind of easily. Just this last part, 100 cycles in 492 seconds. This talks about the period. Now you can do it in many ways. One with the frequency, which is the one that I did here, or you can just say 100 cycles per 492 seconds. If 100 cycles takes 492 seconds, how many will take one single cycle? Just divide by 1,000. Okay, if you want to know what one did, so it's going to be 492 divided by 100, so it's going to give you 4.92. You can do it in many ways, and the one that I recommend is here because period, you can do it with the formula. Period is equal to frequency raised to the negative first power. This is the frequency, the equation for frequency, times per second or cycles per second, and then the answer that you have, you will use this key in your calculator, and there you go, 0.203, look, 4.92. Okay, it's easier, and then you just plug in the values in the formula, and that's it. Okay, let's do one more example. You need to know the height of a tower, but darkness obscures the ceiling. You know that a pendulum extending from the ceiling almost touches the floor, and that its period is 12 seconds. How tall is the tower? Pretty common in physics, as we already know. Now, typical situation. You wonder about how tall a tower is or how tall a building is. And you say, okay, now I can use physics to do this. It doesn't happen very often, but when it happens, just to let you know that you can use it. Okay. Now, what are the givens in this exercise? It's giving me a period of 12 seconds. Now it's asking me how tall is the tower. Now, to understand this problem, or if you want to visualize it a little bit better, just imagine that this is the tower that you want to know its height, okay? And there's a pendulum right here from the ceiling and almost touching the floor, and that its period is 12 seconds. Now from that you want to know how tall the tower is. So if we're talking about height, right here we're talking about the pendulum's length. So let's see how to solve the problem. First we take the givens. We already did the drawing. In the drawing I plug all the givens that I had. I have my period, which is 12 seconds, and I have my unknown, which is length. I don't know what is it, so I need to find it. If I need to find it, I will use the equation that I have here for length, which is length equals the period over 2 pi to the second power times gravity. The problem is not specifying any different, that we're in a different planet. We're going to assume that we are here on Earth. So gravity on Earth, you already know, 9.81. So you know we have 12 seconds. We have 2 pi to the second power times 9.81 meters over second square. So let's do this. 12 divided by 2 divided by pi, raise it to the second power times 9.81. Length equals 35.78 meters. So how tall the tower is? Okay, the tower is 35.78 meters long. Well, not long, tall. And that's it, guys. This is it for today. I hope you had enjoyed the class. Sorry for the mistake before, but I did the correction already. This is the right formula. Okay, bye bye.